and that change can be written in terms of reactant or in terms of product. म्हणजे reaction the speed we can write in terms of reactant and also in terms of product. Rate is equal to K into concentration of A raised to X, concentration of B raised to Y. If the power is 1, it depends linearly. If the power is 2, it depends exponentially. Hello everyone, welcome back to SantChemistry. How are you all? I hope you all are awesome because I am awesome. So today in this video, we will start with the next chapter from 12th chemistry, and that is Chemical Kinetics. Very interesting chapter, I won't say easy, but must chapter. Okay? आता easy की नाही ते after the lecture you can write in the comments. Okay? चला. Let's begin with chemical kinetics. So to begin with, chemical kinetics. Very first thing, what comes in our mind when we say kinetics? Kinetics means something is in motion. बरोबर है? Kinetic energy. So energy of a moving object. Here also, when we say kinetics, we are talking about something in motion. म्हणजे काहीतरी मूव्ह करत आहे. आता मूव्ह काय करत आहे याच्यामध्ये? केमिकल्स कायनेटिक्स. म्हणजे केमिकल्स आर इन मोशन. कळतंय? So whenever something is moving, we can find out its speed. So इथे if I say speed of a reaction, इथे आपण काढणार रिएक्शनचं स्पीड. Instead of writing that word speed, we can write the word that we need, which is rate of chemical reaction. Okay? आता एक सिंपल प्रश्न, स्पीड म्हणजे काय? समथिंग इज चेंजिंग विथ रिस्पेक्ट टू टाइम. बरोबर? समथिंग इज चेंजिंग विथ रिस्पेक्ट टू टाइम. When I say chemicals, एक simple example here, reactant and product. In a reaction we have reactants, we have products. Reactants are maximum at the beginning and products are zero. Nothing. बरोबर आहे? As reaction progresses with time, what happens? Reactant go on decreasing and product go on increasing. एका मोमेंटला ते सेम होतात, not useful. So reactant goes on decreasing, product goes on increasing. एक अशी वेळ येईल, reactant संपला, reactant is over and product is maximum. Getting my point? So what is happening here? What is changing? Concentration or amount of reactant and amount of product are changing. Are we okay with it? Yes? Fine. So reactants are decreasing and products are increasing. To begin with, we can say rate of chemical reaction or rate of reaction is equal to change in concentration. Concentration means amount. So change in concentration upon change in time. That is called as rate of chemical reaction. And that change can be written in terms of reactant or in terms of product. म्हणजे reaction the speed we can write in terms of reactant and also in terms of product. In terms of reactant, reactants are decreasing. So we can say rate of consumption. Rate of consumption. Because reactants are being consumed. Rate of consumption, it will be equal to decrease because reactants are decreasing. So decrease in, I am using shortcut here, concentration of reactant. Concentration साठी आपण वापरला square bracket. I hope you know. Square bracket means concentration. So decrease in concentration of reactant upon change in time. Reactant amount decreases, but time never decreases. So time only change in time. समझते हैं? Okay. At the same time, we can use this color. This color actually indicates green. Green म्हणजे वाढतोय. So rate of formation. आता in a reaction, what is being formed? Logical. Products are being formed. So we can say increase in concentration of product upon, again time changes, so change in time. Are we okay with it? Is this easy? So reactants are decreasing, hence we can say rate of consumption, they are being consumed. Products are increasing, hence we say rate of formation of product. Okay, easy? Okay, note this, and then we'll go for the next concept. आता याला आपण ना we can write in two different ways. एक तर average rate आणि second म्हणजे instantaneous rate. So what is average? Average म्हणजे काय? From beginning to end, we are finding out the overall rate. I don't care about the at particular moment. I care about the overall thing. समझते? So if I say average rate will be average rate of reaction. This will be rate. आता समजा इथे आपण घेतलं एक्झाम्पल, if I have this reaction, reactant giving product, if I say R giving P is my reaction, so here we can say rate is equal to, आता reactant काय होतोय? Consume होतोय. So as we say decrease in concentration, for decrease I am writing minus average ना, मग delta, change is large start to end, so we say delta concentration of R upon delta T. समझते हैं? Delta means change, minus means negative, basically decrease, so decrease represents minus sign, minus delta concentration of R upon delta T is equal to, now in terms of products are being formed, so plus delta means change, concentration means square bracket, and delta T. So how to read this? Rate of reaction is equal to, or to be more precise, average rate of reaction is equal to minus delta concentration of R upon delta T. Delta represents large change. Okay, and plus means formation, so plus means product means plus, reactant means minus means reactant. Very good. Are we okay? याला म्हणतो आपण average rate. At the same time, if I say instantaneous rate, now what is meant by instantaneous rate of reaction? When I say average, समजा reaction is occurring for 10 minutes, मग त्या overall 10 minutes मध्ये काय स्पीड होतं? That will be average. But instantaneous means, if I say after 5 minutes, what is the speed of reaction? If I say after 3.2 minutes, what is the reaction? So at particular instant, एका particular वेळेला, if you are trying to find out the speed, we call it average, instantaneous speed. Sorry. Okay, we call it instantaneous speed. So now सगळं लॉजिक सेम, just instead of delta we write small change. म्हणजे for this reaction we'll say instantaneous rate is equal to minus, reactant la minus sign, this is only changing, instead of writing delta we'll write D, so D concentration of R upon dt is equal to plus D concentration of P upon dt. Are we okay with it? Yes? Going well? Simple. If okay, note this and please practice it by yourself. Okay, hold on. We'll move to the next concept also. At the same time, let me keep it here aside. Ata samja, if I give you the next one, reaction is A plus B giving C plus D. This is the reaction. And in this reaction, we have small coefficients A, B, C and D. These are coefficients given in white color. If I want to write instantaneous rate for this, average instantaneous, logic completely same. Instead of delta, here we'll use D. I am going for right now instantaneous rate. So for this, these two are reactants, these two are products. Let's write the rate of reaction. It will be, if it is reactant, minus sign. D for instantaneous rate, concentration of A upon dt. बरोबर है? Is equal to, second reactant na, I know here we have plus sign, but we write rate of reaction in terms of individual reactant and individual product. Are we okay? Okay. So here we will say minus d concentration of B upon dt. Now here reactant, so minus sign. Easy? Similarly for product now. Product म्हणजे plus d concentration of C upon dt. Are we okay? One more thing. Now the last one. So plus d concentration of D upon dt. आता उरली एक गोष्ट, small abcd. So their coefficients, remember, coefficients of each reactant and product will go 1 upon. म्हणजे काय? Minus d concentration of A upon dt. This coefficient goes 1 upon. This coefficient goes 1 upon. This coefficient 1 upon. This coefficient 1 upon. समझता है? So how to write this? The coefficients are to be written 1 upon. Reactants having minus sign, products having plus sign. Are we okay? If yes, let me give two examples. One of them I'll solve, one of them you have to solve and write answer in comments. Okay? Chala, patkan. So example number 1. If I give you N2 plus 3H2 giving 2 NH3. For this reactants product. So if you write the instantaneous rate, it will be minus d concentration of N2. Why N2? Why minus sign? Because N2 is a reactant. Very good. dt is equal to H2 is also a reactant. So we'll write minus. This will go in 1 upon coefficient. So d concentration of H2 upon dt. Are we okay? If yes, the next one. Now it is on the right hand side. So it is product. We'll write plus 1 upon 2 d concentration of NH3 upon dt. Are we okay? If yes, I am giving one more example. हे तुम्हाला ट्राय करायचं आहे, याचा आन्सर मी व्हिडिओ मध्ये देणार नाही. ओके, चला. सेकंड इज N2O5, I guess 2 आला पाहिजे इथे. Decomposes to give 4NO2 plus O2. Okay. Write the instantaneous rate of this one and I want the answer to be in comments. ठीक है, ये पटकन करा. Now we'll discuss the next concept that is called as rate law. Okay, चला पटकन. Okay, now the next concept is rate law. So what is rate law? Next is rate law. When we say rate law, आता बघा एक सिंपल प्रश्न आहे, ह्याच्या आधी आपण काढलं. We have studied rate of reaction. Okay, by the way, to practice we have some more questions here. Here try this, you can try from textbook. You can also try this one. जेवढे जमतील तेवढे जास्त स्वतःहून ट्राय करून घ्या. ओके, हे आन्सर, हे क्वेश्चन नीट सॉल्व करून घ्या. यू विल गेट अ बेटर आयडिया. इफ यू आर एबल टू सॉल्व दिस फॉर इन्स्टंटेनियस रेट, याचा अर्थ तुम्हाला इन्स्टंटेनियस रेट चांगला जमला. ओके, चलो. इफ येस, नाउ विल कम टू द नेक्स्ट कन्सेप्ट कॉल्ड एज रेट लॉ. आता रेट लॉ म्हणजे काय? सो इट इज गिवन हियर. The rate of reaction at a given time is proportional to its molar concentration at that time. raised to simple powers. The rate of reaction at a given time is proportional to its molar concentration at that time raised to simple powers. Are we okay with it? Okay. If yes, याला म्हणतो आपण रेट लॉ. याचा अर्थ काय बघा? The simple meaning of this is, if I am saying I have this reaction, if I say rate law, the definition we have just studied, आता मी ते लिहिणार नाहीये, I am just giving directly example. If I have this reaction AA plus BB giving CC plus DD, जादू कलर चेंज झाला. Okay, आता for this if I say rate law says rate is proportional to concentration of reactants. एक असेल तर एक, if we have two तर two, if we have multiple तर multiple, no problem. Raised to simple powers x आणि y. समजते आपल्याला? That is what we call rate law. Rate law says rate of reaction is proportional to reactant concentration A आणि B, capital A capital B यांच्या कोएफिशिएंट्सचं इथं आपल्याला काहीच करायचं नाहीये. ओके, समजतंय? I'll repeat. As per rate law, the rate of reaction is proportional to reactant concentration only. Reactant म्हणजे arrowच्या लेफ्टला असतो तो, बरोबर? Raised to simple powers. If I remove this sign of proportionality, we get rate is equal to K into concentration of A raised to X, concentration of B raised to Y. समझता है? Important point from this chapter, we call it equation star. Okay, at the beginning we'll start marking stars, म्हणजे at the end of the chapter we'll collect all stars together, and that can be your important formula list from chapter. हे तुम्ही प्रत्येक चॅप्टर मध्ये फॉलो करू शकता. ओके, नाउ इन दिस we can say where K is equal to rate constant, X plus Y is equal to order of reaction. आता ऑर्डर ऑफ रिएक्शन म्हणजे रिएक्शनचा रेट कॉन्सन्ट्रेशन ऑफ रिएक्टंट वर डिपेंड कसा करतो. हाऊ डज अ रेट ऑफ रिएक्शन डिपेंड्स ऑन कॉन्सन्ट्रेशन. फॉर दॅट वी हॅव एक्स प्लस वाय. वी विल टॉक अबाउट दॅट इन डेप्थ फॉर इन अ वाइल. ओके, बट फॉर नाउ फोकस हियर की कॉन्सन्ट्रेशन ऑफ ए इज कॉन्सन्ट्रेशन ऑफ ए. त्याची पॉवर जर एक्स असेल तर इट मीन्स X is the order of reaction in terms of A. Y is the order of reaction in terms of B. समजतंय? ओके, समजत नसेल तर 2 मिनिट थांबा, आपण याचं प्रॉपर अंडरस्टँडिंग करून घेऊ विथ एक्झाम्पल. आता सॉरी, इफ आय से व्हॅल्यू ऑफ रेट, नाही ऑर्डर, लेट्स से ऑर्डर ऑफ रिएक्शन. आता order of reaction is x and y na. X plus y is the order of reaction. Suppose if I say case number 1, x is equal to 1 and y is equal to also 1. जर आपण दोन्ही पण 1 1 पुट केलं तर काय होईल? Rate is equal to K into concentration of A raised to x into concentration of B raised to y. हा आपला फॉर्म्युला आहे, इक्वेशन नंबर 1. याच्यामध्ये if I put value of x is equal to 1, so if I say value of x is equal to 1, A raised to 1, concentration of B raised to 1, K constant असा पण, so reactionचा rate change होतो, but by what value we don't know. So I am saying rate of reaction will change by factor, let's say P, factor P. समजता है? So let's find the impact of this. आता सपोज जर आपण कॉन्सन्ट्रेशन ऑफ ए ला डबल केलं, इफ आय डबल कॉन्सन्ट्रेशन ऑफ ए, त्याची पॉवर 1 आहे. इफ द पॉवर ऑफ ए इज 1 and if I double the concentration of A, रिएक्शनचा रेट P ने चेंज होतो. तो what is that value P? Let's find out. So here we can simply say equation 2 divided by equation 1. If we do this, what do we get? P into rate is equal to K. I'll take this 2 out. So 2 into concentration of A raised to 1 into concentration of B raised to 1 upon equation number 1 म्हणजे rate is equal to K into concentration of A raised to X concentration of B raised to Y. जर आपण दोघांच्या व्हॅल्यू इथे 1 1 पुट केल्या सो दिस गोज, दिस ऑल्सो गोज. मग इथे पण ते येणार नाही, इथे पण ते येणार नाही. समजते आपल्याला हे? इझी? ओके. मग आता मला फाइंड करायचं आहे की जर इफ द ऑर्डर इज 1 and if I double concentration of reactant, रिएक्शनच्या रेटला किती फरक पडतो? फॉर दॅट एकदम सिंपल पॉइंट, we can cancel this, we can cancel this and this also. What remains? P is equal to 2. What do you conclude from this? Yes, can I say here, जर त्याची power is 1, if the order is 1, if the order of reactant is 1, then doubling the concentration of that reactant also doubles the rate of reaction. Are we okay with it? If I double concentration, it will double the rate of reaction. समझता है? Okay, that is when the order is 1. So we'll write that. Therefore, if the order of reaction is 1, doubling the concentration doubles the rate of reaction. Are we all okay with this? समजते हैं? So इथे आपण स्टार्ट केलं with rate of reaction. We got concept called as order of reaction. Now if the order is 1, I give you the dependence. Dependency basically is linear. If this is double, power 1 असेल तर, if reactant is double, reaction rate also doubles. If reactant is tripled, reaction rate also will be tripled. कहता है if power is 1, dependency is linear. Now second case, let me keep it here as it is. In second case, if I say number 2, x equals to 2 and y equals to 1, we are taking y only for reference, then we can say rate is equal to K into concentration of A. Instead of x we'll write 2 into concentration of B, instead of y we'll write 1. So 1 ला काय नाही ला काय सेम असतो. Again equation number 1. If now I say that we have doubled the concentration of A, जर मी A ला डबल केला, keeping concentration of B same, then the rate of reaction also changes by a factor, let's say Q. इथे आपण त्याला P घेतला होता, इथे आपण त्याला Q घेऊया. समजतंय? इक्वेशन नंबर 2. आता आपण चेक करतोय, if the power is 2, then what is the dependency? Okay, let's see. Again we'll go for equation 2 divided by equation 1, and what we get is Q into rate is equal to K. याला तुला आपण बाहेर काढूया. It will be 2 raised to 2 concentration of A raised to 2 concentration of B raised to 1 divided by equation number 1 is rate is equal to K into concentration of A raised to 2 concentration of B raised to 1 म्हणजे B. Now if you cancel this, what do we get? Rate can be cancelled, K cancelled, concentration of A square cancelled, concentration of B cancelled. What remains? Q is equal to 2 square, means Q is equal to 4. So what do you get here? Can we simply say if the order of reaction is 2, then doubling concentration increases rate by 4 times. समझता है? So here we can say, therefore if the order is 2, then the rate of reaction depends exponentially on concentration of reactant. समजते आपलं हे? If the power is 1, it depends linearly. If the power is 2, it depends exponentially. Are we okay? Going well? पक्का? चलो. If yes, आता थोडंसं पुढे. Third. Case number 3, if I say if x is equal to 0 and y is equal to 1. Remember, order of reaction can be anything. It can be integer, it can be fractional, it can be 0. It can be negative also. So आता आपण घेतो 0 example. If I say x is equal to 0, so rate of reaction will be equal to, rate is equal to k into concentration of A raised to 0, concentration of B raised to y. बरोबर? If we have this, anything raised to 0 काय असतं? 1. बरोबर ना? Anything raised to 0 is 1. जर कुठल्याही नंबरची पॉवर 0 असेल तर त्याची व्हॅल्यू 1 होते. याचा अर्थ we can say rate is equal to k, हा झाला 1, so we can say 1 into concentration of B raised to y. That means rate of reaction is equal to k into concentration of B raised to y, where there is no concentration of A. समजतंय? याचा अर्थ काय? Rate of reaction is independent of concentration of A, right? So here we can say, therefore if the order is 0, the rate of reaction is independent of concentration of that reactant. Are we okay with it? या केसमध्ये रिएक्टंटच्या रेटला त्या कॉन्सन्ट्रेशनचा, कॉन्सन्ट्रेशन ऑफ ए चा काहीही फरक पडत नाही, बिकॉज इट्स पॉवर इज 0. आर वी ओके? गोइंग वेल? So we have seen 3 different conditions. Any query with this? काही असेल रिवाइंड करून बघा, आणि तरी समजलं नाही प्लीज राईट दॅट इन कॉमेंट्स. ओके, चला. इफ अप टू दिस ओके, एक लास्ट केस बघू आपण. एक लास्ट केस इज अबाउट, जर समजा पॉवर इज नेगेटिव्ह. ॲज आय सेड, ऑर्डर ऑफ रिएक्शन कॅन बी एनिथिंग. इफ इट इज नेगेटिव्ह मग काय? सो इन फोर्थ केस वी कॅन से x इक्वल टू -1. आता मी मुद्दाम y घेत नाहीये, x इज इक्वल टू -1. व्हॉट डज दॅट मीन? रेट इज इक्वल टू k इंटू कॉन्सन्ट्रेशन ऑफ A रेज टू -1. आता एक सिंपल प्रश्न आहे, जर त्या -1 ला मला +1 करायचं आहे, ऑप्शन काय? वी कॅन टेक इनवर्स ऑफ दॅट. इनवर्स म्हणजे काय? रेट इज इक्वल टू k इंटू 1 अपॉन कॉन्सन्ट्रेशन ऑफ A. जर मी हा कॉन्स्टंट काढून टाकला तर कॅन आय से रेट इज प्रपोर्शनल टू 1 अपॉन कॉन्सन्ट्रेशन ऑफ A. म्हणजेच काय? इफ रिएक्टंट कॉन्सन्ट्रेशन इंक्रीजेस, रेट ऑफ रिएक्शन डिक्रीजेस. आर वी ओके? येस, व्हेरी गुड. इफ येस, याला आपण घेऊया वर्ड्स मध्ये. देअरफॉर if the order is negative, the rate of reaction decreases when concentration of reactant increases. Okay, are we okay with it? So we have covered all different types of concepts. एकदा मी तुम्ही समोर सगळं ते ठेवून देतो. If it is not visible, please rewind the video and check. ओके, आणि जर काही क्वेरी असतील तर प्लीज राईट दॅट इन कॉमेंट्स. याचे काही एक्झाम्पल्स तुम्हाला करायचे प्रॅक्टिस. आधी याचा स्क्रीनशॉट घ्या, देन आय गिव्ह सम एक्झाम्पल्स ऑल्सो. ओके, टेकन स्क्रीनशॉट. आता लेट्स गो फॉर सम एक्झाम्पल्स हियर. We can take examples here. Try this. Rate of reaction is experimentally found to be proportional to the square of concentration of NO2 म्हणजे power 2. And independent म्हणजे आपण आता बघितलं ना, independent कधी होता? When the power was 0. Right? So this example you can try. Then you can try this example. हे try करून बघा. So page number, textbook page number 122 and page number 123. Try these questions by yourself. For now, we'll stop in this video. जर तुम्हाला काही क्वेरी असेल, राईट दॅट इन कॉमेंट्स. अजूनपर्यंत चॅनलला सबस्क्राईब केलं नसेल तर पटकन सबस्क्राईब करून घ्या, कारण नेक्स्ट व्हिडिओमध्ये आपण याचे अजून क्वेश्चन सॉल्व्ह करणार. अँड वी विल गो फॉर द नेक्स्ट इम्पॉर्टंट टॉपिक विच इज integrated rate law for the first and zero order reactions and त्यांची half life. So stay tuned for the next video. आत्ताच बेल आयकॉन दाबून ठेवा आणि पटकन सबस्क्राईब करा. ओके, टिल देन study well, be healthy and see you in the next video. Bye bye.